start recording the session now. Okay, so any doubts on whatever we have covered so far? And now we've come quite a way. So today we are going to complete visualization. So after that, we have only two sessions on pandas left. That's going to cover the advanced pandas topics so we're going to primarily talk about the pivot and melt, that is the reshaping, and the cross tabulation, and a lot of miscellaneous topics we'll cover in week 10. So if there is any issue, any question up to this point, this is still a good time to ask before we get into the today's content. Anyone? Any issues? Is visualization, whatever we covered last time, is it all clear? Okay, so no problems on that, right? Okay. So we talked about the pie chart, right? That was the last topic that we covered. And we are primarily using the pandas plot here for all the functions. It is still important to be aware of the matplotlib code because pandas uses matplotlib. So you would be using the functions many times. You would be using pandas plot along with some matplotlib code, especially when you want to do some advanced editing. That is why it becomes important to understand both the aspects. Okay, so now we come to histogram. So can anyone tell me what a histogram is? Good. Yes, so we can try to plot where the data is not continuous, but that's going to be more like a bar chart, right? So the plot is not going to be very relevant, but it would be very relevant when we have continuous data. And what we really look at when we look at a histogram, when we plot a histogram, is we look at the distribution. So distribution is the key word here. So when I so look at this plot here that I've created. Uh, it is the histogram of win by wickets. Please note that I have filtered the data first. So if you just see this up to this part of the code, what I have done is that rather than taking plotting the histogram on the entire data and the win by wicket column, why did I filter out? Because uh, in IPL data, of course, we understand IPL data much better, and we know that a match, depending on the team batting first one versus the team batting second one, it's going to be either the win by wickets or win by runs, right? So the win by wicket, if that number is zero, those rows are not really relevant if I want to find the histogram of the win by wickets, because all the matches which were win by whatever number of runs, basically the match was won by team batting first, then the win by wickets is going to be zero. So if I don't filter out these rows, then it gives me this kind of okay. Okay, I'll have to just let me just import because otherwise it'll just keep giving me problem. Okay. So what is happening here is that I'm getting this very high column of the values where win by wicket is 0. So I'm just trying to filter out those rows. So now I've filtered out the rows where win by wicket is not, or I'm just rather keeping the rows where win by wicket is not 0 and then plotting the histogram. So this is what I get. So what does it tell me? It tells me, so it is following, if you all must be aware of the normal distribution, right? So what is this data? What is this graph or histogram telling me? It's telling me that this is more like the range. Of course, we know that the data could be in the range of 0 to 10, and the highest value, as it occurs in most normally distributed data, is somewhere in the range of 6 to 7 wickets. So maximum number of matches were won by 6 7 wickets, and then on both the ends it is tapering down. So this is the normal distribution of the data. Now, of course, not all the data necessarily is normally distributed. So now what are we doing is that we are plotting the histogram of win by runs. So this was the win by wickets. The range is of course 0 to 10. Win by runs is going to follow a slightly different format. So here you can see there is a, so when the histogram is more of this format where it is the tail is longer on any one end, it could be on the right or the left. So this is the right skew. So here the data is not normally distributed. We see that there are more number of matches which are won, by 0 to 20 runs, and then continuously that goes down. So what exactly happens in histogram? How is this kind of a plot generated? So for example, here I have chosen a parameter. So the histogram has a parameter called bins, and I can change the value of that bins. So, or rather the size of the bin. So if I make the bin size 5, this is the kind of graph that I get. And if I make the bin size say 50, then this is the kind of graph that gets generated. So what exactly is happening here? Uh, can someone tell me? And as you can see, I've written here the default value is 10. So if you want to stick with that default 10, then you don't have to even use this parameter. So can someone tell me how exactly uh, does histogram work? So what really is happening in the background? How is the data getting consolidated? Anyone?
Screen means total data is
Uh, okay, I think there is. So what happens really in X and Y, which, yeah, exactly. That's the reason I am trying to, because otherwise it's just this is it. I mean, this is the histogram. What I want to explain to everyone is that what are we doing here? So let me Okay, just adding a cell here. So when I see the I'm just looking, I'm going to focus on the column. So let's say I'm going to say win by runs. Okay, so this is my data, right? Matches dot win by run. Now, of course, there are a lot of these zero values which I'm not interested in. That's the reason I do the filtering. So it gives me a more it gives me only the rows which I'm interested in. So now, after filtering the zero, the rows where win by runs is zero, this is what I get. This is my data point. So I have, say, 261 rows. So I have 261 values, and they are, I can check the max and minimum, but I can tell you, I think the maximum is around 144, and the minimum could be as little as 1. So this is the data that we are looking at. Now we want to find the the range of the data. Now this is a much smaller data. You could have a much larger data. You could have any data that you're looking at might have hundred thousands to millions of rows, and you would have some random bunch of numbers. Now if you want to find the distribution of the data, how is that data distributed, what really do? So histogram is very different from the graphs that you've been looking at so far. There is no x or y values here. Do you all remember the value counts that we did in pandas? What happens in the value count? So let's say you have uh, any data. Yes, the number of times the a particular value appears, right? Now theoretically I can get the value counts of this column, I mean, for this column. So what am I getting? I'm getting the 23. So uh, 9 times whatever the some team won the match by 23 runs. Similarly, 8 times 9 runs, 8 times 10 runs, 8 times 24 runs. But in this case, the value counts is not very relevant. Why? Because our range is much larger. Value count is a very ideal way of getting the feel or the distribution of data when you're dealing with smaller number. So now here, instead of win by runs, if I look at the win by wickets, value count is going to make so much more sense. It's going to in fact give you exactly the same outcome or output as uh, the binning will give you. So now if I check the value counts, what will I get? I get exactly the range that I'm plotting here, right? So 61 and 62 times the teams won by 6 and 7 wickets. So that is the highest number here, right in the middle. And you can see now on both the ends, the values are reducing. So then you have 5 and 8, then you have 9 and 4, then you have 3 and 10, 1 and 2. So this is a very classic normal distribution. So this is exactly what is happening in the binning, and histogram represents the same. Why is it giving us the correct kind of an output? Because the number is already very small. There are just exactly 10 bins. So these, what are bins? Bins are the range of values. Now, in case of win by runs, it wasn't giving us very meaningful output because our range was much higher. Our range was from 1 to 144. So it's a much higher range. Now, if I want to split this range into a more meaningful range like what we saw with win by wickets, ideally, what would you like to do? I would say that, okay, I don't care about each individual number, but I want to see, okay, how many times, how many matches have been won by, say, 0 to 10 runs. Then how many matches were won by 11 to 20 runs. Then 21 to 30 runs, 31 to 40 runs. So those are my bins. And because my range of data is from 1 to 144 in this case, if my bin size is 10, then totally how many bins are going to be generated? 15 bins are going to be generated, right? So that is how my data is split. So what we are plotting here, so value count, it's a purely one single column distribution. It's not the case where you're plotting x against y. It's basically the range of the values and the count. So technically, yeah, that way you can say x and y. But what we are plotting is purely a series. It's just one column and the distribution of the data. But because the range of the values could be much larger, what it does is that it creates a bin. So in fact, in the next session, bin is the range of values. In fact, we are going to talk about this in the next session, but there is a function pd.cut, so that exactly does that. So let me just quickly introduce that to you, so that uh, overall the concept becomes clear, that what are we doing in histogram, because I just don't want to theoretically show you one histogram and then move on. So what it does, once again, the same thing. I pass the series and I uh, also specify the bin size. Okay, and it gives me the range. So I pass my array. So if I try to create, okay, let me get rid of this. Fine. So this is where we are, right? So when I pass my series to the pd.cut, and so this is the range, the bin that got created. Wait, this is not okay. So what is happening here is that for each value, if you remember, so the first match, it was won by whatever number of runs. That runs was in this range. It was between 129 to 144. Let me make the 15. Then my bins will be more meaningful. So now, instead of the value in each, so this was my series. So at index number 0, my value was 140. When I use pd.cut, what happened? Instead of the absolute number, my number got assigned to a particular bin. And what I can do is that now I can group by this. So I can say group by this range. So then each of this bin would be one range. And then I can find a count on this, which will give me the same answer. So coming back to Mayank's question, what happens in histogram is that instead of x and y, what I have is the range. So my data is split. So when I have, coming back to this histogram to make it more meaningful. So my range is, so I have created 15 bins, and I know that my range is from 1 to 144. So you can see my first bin is 134.4 to 144. So basically I'm getting bin with the range of, around 10. So let's, for theoretical sake, let's keep it simple. So let's say that my bins are 1 to 10, 11 to 20, and so on. So my each number, as you can see, the number has disappeared now. When you saw the series earlier, the series looked like this, right? It was 140, 33, 6, 66. But now after passing it to pd.cut, what I got? The first number 140 got assigned to this particular bin. The second number 36 got assigned to this bin. The third number 6 got assigned to a particular bin. And these bins are constant. So you can see these bins reappearing. Point 0.8 to 10. Again, there is a point 0.8 to 10. So now it is very easy for me to get the count of this. In fact, I can also find the value counts of this. So now what does it give me? Now it gives me that there are so many values which are in this range from 0 to 10. And then there are so many between 10 and 20. And then there are so many between 20 and 30. And then between 30 and 40. And then 40 and 50. And as you can see, this graph it has a right skew. So rather than it following a normal distribution, which we saw in the case of win by wickets, it has a very high right skew. So as we are going towards the higher bin range, the number is reducing. So this is what your histogram does without you having to use the code of the cut. It automatically generates the bins that you generated here. This, I have kept the bin size same as in this plot, right? The bins I've again created 15. So it gives me the identical result as what the histogram is showing. So it is, the data is distributed in a range, and then each value is categorized to that particular range. uh, I'm not sure, but most of you should remember something like this, done in school. I remember this in school in the maths, when we started with a very basic statistics, that when you have been given, say you have given a range of marks, then those marks could be random. If say you have a range of score 34, 56, 78, 3, 91, and you want to categorize it. So you say your ranges are 0 to 20. So you say that, okay, 0 to 20, how many values are in the range? I have one. Then 21 to 40, how many numbers are appearing in 21 to 40? So we have again 1, and so on. So that is what binning the data into a particular range and then plotting that. That is what your histogram is giving you. Is this clear now? What's really going on in the background? So here what you have in the X is, it's just nothing but the number. It does not give you the range, because the range is continuous, as you can see. And that is why there is a unique way of representing it. You can see there is a round bracket on one side and the square on one side. It shows that it's a continuous range. So you can see this number reappearing, 10.533. Similarly here, 29.6. So at the x-axis, all you see is those the values. So in our case, win by runs. And as I told you, we have the range is from 1 to 144. And then what we are getting is the count. If I increase the bins, let's say I make it 30, then there's going to be a much higher granularity here. And if I make it very high, it's going to end up looking like more like a bar graph. So if I say make it 100, it will just look like individual bar, because practically each run is a range in itself. So my range is from 1 to 140. If I make it 140, it's going to be, literally each run is going to be the range. It automatically creates the range. So you don't specify the range. All you specify is the number. Bin is not the value inside. You are not dictating that. All you are saying is that I want to create the buckets, so many buckets, it is going to automatically assign each value to that particular bucket depending on the number of bins that you want. So here my bins are 15. So you can see, this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, there is nothing, 14 and 15. So 15 ranges have got created. Same 15 you can see here. It's just a different code. Histogram is doing this calculation in the background. Here I've shown you how the calculations really work. So it created the ranges, and then it counted the value for each range for the entire series. Now imagine you have data with 100,000 rows, and with one line of code you are able to get this kind of an outcome, that this is the range of values. So not every data can be represented by pure mean median mode, right? I mean, let's say you have uh, I can take an example of the salaries of people, right? And it could be for a very large organization. Let's say the salary of all the employees of Infosys. Now, Infosys would have, I don't know how many employees overall, totally. I mean, I'm sure it's going to be upwards of 100,000, right? Now, if I just find the mean value of that, it's going to average the salary of the office boy and to the CEO, right? CEO and CFOs. So that's not going to make much sense. But if I do the binning like this, what will it give me? It will give me the range. So for example, I will get ranges like salaries of say 2 to 4 crore. So there are so many employees in that range, or 1 crore to 3 crore, so many employees, and then something like that. So that data, that statistic would be much more relevant. It would convey much better information than finding a pure mean or a median. Correct. So that is what you can do using the binning. Of course, even then, even with doing the binning, the salary of CEO and CFO is still going to be an outlier. That's a different thing. But overall, do you get the concept where this becomes relevant? Actually, that's an interesting question, Saurabh. Even I was wondering, but let us go through the documentation. I don't know if you can control the range. You can just control the bins. So I can check that. Because here, of course, the decimal is not very relevant. So, so we have the bins. Okay, so here you can specify a sequence of scalar instead of specifying the number of bins. So what I could have done was I could have specified my entire range. So I could have said 0, 10, 20. Actually, I could just say 0, 150, and let's say 10. So then my ranges are, so what I have done is that now for the bins, I passed a list of numbers from 0, 10, 20, 30, 40. So I got a little more clean kind of the ranges. So yes, you can do that. No problems. I mean, even I had to refer the documentation. So that's uh, the hard fact. Overall, the concept is clear. Is the concept clear? I think that's the question. Yes. So we are creating whatever predefined ranges, and then the count is incremented for each range. So we get totally, how many. So in fact, even histogram might have a provision for defining the range to a whole number instead of the bin size. So I think even here you can pass the range instead of the number. So now my ranges are in that 0 to 10. You can see, it's getting split at the grid. So 0 to 10, 10 to 20, 20 to 30, 30 to 40, so on. So my bins are into that whole number range. Overall histogram, is this clear or not? So going back to that question of X and Y, it's the X and Y axis is not really relevant here because it is very similar to the value count. So that is one simple way of understanding what happens in value count. It's a series method. It's not where you're grouping by something and then applying a function. It's just the whole series. You try to find the count of the range of the values. So same thing is happening here. The only difference being that if your range is much higher, then the value count doesn't is not very relevant anymore. So in that case, we first create the bins and then find the value count. But in principle, that's what we are doing. We are finding the value count, but for a range of numbers rather than each individual number. Default is 10. So if I don't specify the default, it's going to be 10. But it's going to be 10 bins. So in this case, our range of 1 to 144 will be divided into 10 bins. So our each bin is going to be something like 0 to 14 and so on. So if I get rid of this and I say bins is equal to 10, uh, then my bins are more like in this range, right? I mean, close to 1 to 15 and then 15 to 29. So around 14. The range is around 40 for each range. Yes, that's what we did here, right? I mean, so there are two ways of doing it. One is the number of bins. So we specify the number and we increment or decrement that. Second is you specify the list. So I could have said bins equal to, I could also have a predefined bin. So I can say 0, 5, 10. 20, 25, 150, and then pass bins is equal to bins. I hope you understand this part of the code. So I have already created the list, the variable here, and then I'm passing that list to the cut. So now my bins are, so because I see, because I know in my particular data, most of my values are in that, up to win by runs up to 40, and then it tapers down. So my the bins at the higher number, I want to keep them much larger, but I want finer granularity in the at the smaller range. So I want the bins to be 0 to 5, 5 to 10, 10 to 15, 15 to 20, and then after that I want it to be a much so I forgot to add a 15 here. So this is the range I want, and then I want maybe just, you know 50 to 100, 100 to 150. So I give you an example of the Infosys salaries. So let's say we could have a range of five whatever, 2 to 5 lakhs, 5 to 10, 10 to 15, 15 to 20, up to 50 lakhs. We can have a more general range, and then we can say, okay, how many are up to 50, from 50 to 100 lakh, 50 lakhs to 1 crore, and then we could say above 1 crore. So then any who's in that range of above 1 crore goes into that outlier. So it doesn't have to be uniform bin size. You can specify it as per your data. Is this clear? We are going to once again, it did not pick. I picked these values right now. I could have picked a 0 to 10 here. See, this is the range of my this particular data. So if I'm not, I'm going to go back to the bins of 15 bins. So I know my data is right skewed. Most of my data point is in this range of 0 to 40. After that, I have very few values. So now I want the bins to be created with a finer granularity at the smaller scale, say up to 40. So I want up to 40, I want the number to be, in the range of 5. So 0 to 5, 5 to 10, 10 to 15, 15 to 20, 25, 30, 35, 40. And after that, I don't mind, the range could be much larger. So I want, say, 40 to 50, 50 to 100, 100 to 150. I could do that. So the range that I specify is completely up to me, depends on the kind of data I have. And is this clear now? Okay. Otherwise, I can create another example and then I can show you. Is this clear? I was just going to create just a dummy example of some salaries. But if it is clear, then I would just save time here. So everyone, the whole idea of histogram. Okay, we don't even need a data frame here. So uh, just it's going to be a lot of zeros. Okay, let me use So this is my salary data. Okay, I've just generated a data of random numbers. Of course, this is a pure random number. So what is going to value count is still not going to work because these are absolute. So you can see there is a 4 lakh 61 and then there's 5 lakh. No, is this? No, this is 53 lakhs. There's 46 lakhs, and also there is a 9 lakh, and then there is a 6 lakhs, and so on. So you are having a full range. If you try to find the value count, it's not going to find two numbers which are same. So it's going to literally return those all the 50 values. I could also have a 5,000 here. Okay. And let me make this 5 crores. Okay. So now I have 5,000 values in my series called salaries. And you can see the ranges are like there's a 10 lakhs and 42. How do I find the range? What I'm interested in is broadly, the range and the number of employees who are in that range. Of course, this is random, so my the number is also going to be more random, but that's okay because I don't want to individually sit and count. So that's why I made use of the random here. So without the bin argument, what is going to happen? I have to specify the bins. Okay. I thought it would take default 10. So these are the bins that got generated. And what are the default bins? 5 to 10 lakhs and 10 to 15 and so on. Okay. So I can now use the value counts. The bins, it's a much larger number. So we should have the bins to be more like 20. So this is what I get. Of course, it's random. So it's just uniformly, I don't know, I'm getting a more uniform count. So all are something like 240, 250. Correct. Now, what I could say is that instead of specifying the bins to be like just, dividing the value into 20 uniform bins, I want to say how many are in the range of, say, 0 to 500,000. So 5 lakhs to 10 lakhs. I hope I'm getting my zeros correct. To whatever, 20, 30, 40, and then directly. So I could have this range. So now what does it tell me? That okay, I have so many employees in this range. Say I could have had a 52 lakhs to 1 crore. Now because I've created random, it is just giving me a uniform number. But for the actual salary kind of an example, I would get that okay, there are so many employees who are only that smaller number which is earning more than 50 lakhs, or a much smaller number earning more than 2 crores, say. But I would have a much larger number in this, more standard ranges. So that is why it becomes important to sometimes have a more custom range rather than uniform range. No, then the histogram will start from uh, a much higher number. So here in this case, for example, you saw that the histogram, it started from point 0.8, not 0. So here I remove this range. So you can see the smallest number. So I see a 5 lakhs to 675. Let me make it small so it's easier to see. So where is my smallest range starting from? It's starting from, no, my values are from 100,000. So it should be there somewhere. But yeah, it's definitely not starting from 0. Okay, it's starting from 56,000. So my range is starting from 100,000. So it's picked up the number from 56,000 to 5 lakh. And then it has picked up uniform range. Is this clear? It is a pure value count, but on a range rather than an individual number or a value. So this purely gives us how my data is distributed, right? So uh, most values or numbers in the nature, they follow the normal distribution. But then there are values which have a more right skew or a left skew. And where does this become meaningful? It is picking a random range, so we are not controlling it. Uh, it has picked up probably on the basis of the highest value that it encountered, or purely just on the basis of the number. In fact, if I change this, most likely the smallest number will also change accordingly. So now you can see when I made the bins 20, now my smallest number is 60,000 instead of the 50 odd what it was picking up earlier. So it just tries to somehow create uniform bins. So in this case, the number of bins you don't have really a control over from where, what are your bins. If you want that control, all you have to do is you have to pass a list that I already showed you. We are going to talk about the cut in the next session. So don't worry about this. The reason I showed you this code was so that you understand what is really happening in the histogram. Histogram is just a plot of this, a plot of these numbers. If you understand that part, it is good enough right now. And the parameters, because it's essentially doing the same thing, it remains the same. So once again, you have to specify the bins, which could be either in the form of a number or in the form of the list, the range of values basically. And when we start machine learning, we are going to see the utility of this. Uh, there is no value here. I have to specify the value. I didn't complete this. So I have to specify, say, 100,000, 500,000, 900,000, so on. You know, if I create these bins, only those numbers got included, rest got eliminated. I mean, rest are not counted. Say I'm only interested in the salaries up to 13 lakhs. So I did that. Yeah, no, it was, it won't have any meaning, right? I mean, if you pass empty bin. So everyone, is it clear? We ended up spending much longer in histogram than I expected, which is fine overall as a concept if it is clear. So as I was saying, when we start statistics and machine learning, once again, so we are going to talk about uh, the PD dot cut in the advanced pandas anyway. And then when we come to stats and machine learning, we're going to talk about the utility of it. Why is it important? So for example, let's say you have to fill the missing value in your data frame. As I was saying when I introduced the DA with Python, that you cannot apply any machine learning algorithm on the data so long as it has any missing value. So the pretty much the first step is to fill the missing values. apart from, of course, all the consolidation. So that you're going to do anyway. And when you're filling the missing values, it becomes important. So the most intuitive way of filling the missing values to fill it by the mean. But in this case, what is the mean? Mean is somewhere in the more close to, a higher value, correct? But you know that most of your data is actually lying in the range of 0 to 40. So in this case, if there is a missing value in the win by runs uh, column and you want to fill it, would it be prudent to fill that missing value with say a 70, or would it be prudent to fill it with say a 20 or a 25? Anyone? Everyone's very quiet. I think, did I manage to confuse you all, or did I manage to clear that out? Yes, so it would be prudent to fill the missing value with a smaller range number, right, in this particular data, because there is a very high right skew. So it becomes important to understand the distribution of the data before we proceed. So when I was saying that, the exploratory analysis of the data, the in that case, apart from the overall grouping and finding, so when we say that plotting is used very extensively in exploratory data analysis, what do we do in that case? In that case, the data scientists, they first, when you see IPL data, we've been working with it for past 7, 8, 9 sessions. Plus, we all are aware of the structure of IPL. You know what? If there is a column called win by run, we know in principle what is the meaning of win by run or win by wicket or a bowler or the batsman. Let's say you have a totally unknown column. Many times you have a data which doesn't even have the columns with relevant names. You have a data with 100 columns, and the column names are column 1, column 2, column 3 up to column 100. So you have absolutely no visibility into what the data is conveying. How do you try to make sense out of that data? So in that case, all you have to do is that you have to plot few graphs to see how your data is placed. So in that case, this kind of graph becomes important. So how is your data distributed, for example? So you need to see the histogram. You need to plot histogram of each and every column, and quickly see that how is my data distributed. And then, as I was giving an example of filling the missing value, that is another use case where you fill on the basis of the distribution of the data. Now, in this case, if there is a missing value, of course, I'm fine filling the missing value by the mean, because this is a normal distribution. But in case of any right or the left skew, it won't be ideal to fill the missing value by the mean value. So you may have to fill with a median or a mode, right? So that is the kind of understanding that you need to develop of your data before you proceed. And these all plots they put together, they give you that. So now is this clear? Great. So the next one is box plot. So let's say we have this data frame. This is how it looks like. uh, did we talk about describe? In the first session of pandas, we talked about few basic functions that we quickly try to. Yes, exactly. So I'm glad that you all remember it. So what would describe? Yes, I'm just going to do this. So if when I execute the cell, you will see what is described doing it. Can you tell me? Do you remember? What will it do before I execute this cell? I would like to know from you, Mike. Yeah, it just literally describes the data. Yes, exactly. So you remember it very well. So it gives me the statistical summary. So for each column, I'm getting the count, of course, remains the same because your pandas data frame, it necessarily has to have same number of rows. Even if it has unequal number of values, the rest of the values will get filled by nan. But the number remains, the count remains the same. The mean for each column. So the column number 0, the mean is 0.5. And interestingly, it is more or less in that range for each column because I created a column of random numbers in this particular range from 10 to. So then you have the standard deviation and you have the minimum, first quartile, second, third, and the maximum. So what is this 25%, 50%, and 75%? What does that represent? Anyone? When I say this 25%, 50%, and 75%, yes. And now let's look at the box plot of the same data. So now this is the box plot. So what is it giving us? So the colors may not be very, very clear here, but let's see. So you have these two kind of the outer boundary, and then there is a box with a green line in the center. So what is the lower end of the green line? That is your 25 percentile, 25, the first quartile, it's called, which is 0.37. And the outer boundary of the box is this number, which is 0.65, the 75%. And the green, the line, is the, okay, I thought it would be the mean value. Let's see. And the two numbers at the end, they are the minimum, which is 0.21 in this case, and the maximum, which is 0.79 in this case. So, in a very concise way, it gives me the numeric summary of my data. And box plot will be generated when I directly call the box plot on the data frame. Each and every the box plot, the boxes will be generated for each and every numeric column, right? So this is the description of what our boxes, what I just explained to you. So there are each box is corresponding to each column. And okay, so the median, the green line is not mean, it is the median. That is why it is not matching with any of the number in my describe value. So this is the median. And we have the lower edge of the box is the 25th percentile and the upper edge is the 75th percentile. And these are the extreme observations. So what are we doing here? Why is it saying that deliveries is not? Okay, I was using matches. Okay. So what are we doing here? Okay, there's a question. Sorry. So these both histogram as well as box plot. These are the yeah. We'll come to scatter plot. Don't worry. So these are the statistical summaries. So it gives you, once again, as I said, right, when we are dealing with an unknown data, you are more interested in how your data is distributed and in what range is your value, because your data is not always necessarily going to be uniform. As you can see, when I'm creating a data frame with from random numbers, what is happening? I'm just getting the numbers which are more or less uniformly distributed. That's not going to be the case when you have your real life data, right? It becomes important to see what range your data is falling in. Yeah, Ash, will come to the scatter plot, don't worry. So I'm also giving you a more meaningful example. That's why this was the theoretical example with random numbers. So, Jai Krishna, we're also dealing with that. So, to understand the utility of box plot better. So, what are we doing here? We are grouping this deliveries, which is, of course, the ball by ball summary. We have close to 140, 130, 40K rows. We're grouping it by match ID. So each match and the batting team and the runs. So what does it give me? What is it doing? It's kind of creating the scorecard. Correct. If I group the deliveries data by match ID and the batting team. So for each match ID, there are going to be two batting teams, right? The first inning and the second inning. And then when I sum the total runs, what will I get? I will get the score which was made in the first inning and the second inning. So let me just do this. I have done some more editing on the data because I'm just interested in keeping a few rows. But what does this give me? The match ID 1, the batting team. So KKR made 222, then RCB made 82. Then similarly, match ID 2, first inning, second inning. Match ID 3, first inning, second inning, and so on, right? So which is what I'm capturing in team underscore score. After that, I'm only picking the top values. So in the batting team, so who are my top five batting teams on the basis of the runs that they have made, and I'm filtering the data, the top score on the basis of my top teams, because I'm not interested in creating too many box plots, right? I mean, I just want to create for a few limited teams. So from whatever metric I've used, I came to a conclusion that my top teams are some five teams, these five, and this is the head of that data. So the match ID of course becomes irrelevant. What I'm seeing is that, so now I have this data where I have these five teams and I have the range of runs. So, for example, the top teams, I could say, let's see the top 20. So, I have my five teams and in different matches, what runs they made. So, each and every match that RCB has played in IPL so far, and how many total runs it made. So of course you can understand, right? It's going to be a much different range. So it made as low as 82, and then it also made 135, and it made 166 and 165 again, and so on and so forth. So now here I can just filter this data by batting team, and then I can create a histogram that will give me the distribution of the Bangalore runs. Correct. Now, similarly, instead of histogram, what I can do is that I can create a box plot, which will give me the summary. So that's exactly what I'm doing. I'm grouping this by batting team and I'm creating a box plot. So let me first group by the batting team and create a histogram of total runs. It's also creating a histogram of match ID, which is irrelevant, of course. So, okay, it overlaid. So, fine. But you get the idea. What is really what we are doing is that. So this is the histogram for each team. Correct. So the first one is for the CSK and then the Delhi, and then more or less you can see they are following the normal distribution, right? So sometimes they won by a they made very low score. Sometimes they made very high score. In average, on an average, they made a total score in this range. So this is what my data is conveying, right? Oh, here the two list. Okay. What I did here was, let me break down this code. I grouped the entire data by the batting team and I saw total runs that they have made. I'm not bothered about the season and all, just totally. So, total so far, uh, CSK made so many runs, DD, so on, the total runs made by each team. Then I picked the top five out of that. Okay. So, on the basis of total runs, these are my top five teams. This is the basis that I could have, see, this is totally on the dependent on the analyst, right? I mean, what matrix that person wants to choose. I just wanted to pick the top five teams on the basis of total runs. I could have picked up on the basis of the total number of matches the team has won, or any, it could be anything. But yeah, this is so now this is the data frame that is generated after reset index. Now, what I did out of that, I picked up only the batting team. So, the batting team, it gave me the list because that's all I'm interested in. I'm just interested in the top five names. When I say two list, what's going to happen on this series? When I call two list, what do you think I'll get? On any series, panda series, if I call to list, all the values get converted to list. I could also have called values, which returns a numpy array. In fact, we are going to make use of this values for machine learning. So, as I was saying, machine learning algorithm will be, you'll be able to run it on NumPy array, not a pandas data frame. So, once your data cleaning is done, you would be converting your relevant columns into the an array using the values and then pass it to the algorithm. Yeah. So, but for here, because I'm still in the process of cleaning, what I'm doing is that I'm using toList. So I get the list of those top five teams. And once I got the top five teams, what I did, the team score, basically the score made by each team in each match ID, that particular data frame, I'm filtering it by using, if you remember, isin. That was one way of filtering, right? So isin takes a list as an argument. So I'm passing this list of five teams. So that means it's only going to select the rows where the batting team is one of these five. So here instead of saying team score dot batting team equal to RCB, or batting team equal to CSK, or equal to Punjab. So instead of doing that, I can just simply pass a list of the values and use the isin. You will have to go back, revisit pandas, try some code on your own to remember. We have covered it, but I'm quite sure that unless you've really practiced this, you wouldn't remember. Yeah, we will come to that. Okay. Yeah, this is just the part of the code. I'm not saying that you don't need to understand it, but we have covered all of it. So it would be one way to understand the code is that this file is shared with you. What I did here, I just commented out and saw at each step what is happening. That is the way to understand that what's really happening here. So you can definitely do that. Yes, I understand. Today's session somehow, yeah, it ran into much longer. Histogram, I totally understand, because conceptually, if you don't understand what histogram does, then that has to be sorted, taken care of. So that's why I decided to spend time on it now. So now on that particular data frame that we generated, top teams underscore df, top teams df, when I call box plot, what happens is that I'm grouping it by the batting team. So for each batting team, uh, the box plot gets generated. So here, this is what I'm getting, the same statistic, that the median value, basically the median total runs made by CSK. So as you can see, there is no one number or one answer for this, right? I mean, CSK has made as high as 225 runs and as low as 100 runs. So, and then of course there are some outliers which are even in the range much smaller. So, uh, but this gives you a sense of where does the data lie broadly. So you can see that the median value for CSK is something like 160 or 65, but for DD it is around 150, and then Punjab is also 150, Mumbai is slightly higher. So it just gives you an overall sense of the data. So in that way, it is similar to histogram. Uh, is anyone else having that problem? Because in my panel, it is showing that it's all fine. So you all can hear me, right? You can hear me or you can't hear me, Mayank? Okay. Now the box plot also has a parameter called column. So instead of using group by, so here what I did was on the data frame, I grouped that data frame on batting team, and then I created the box plot of the total runs. Instead of that, I could also use the column parameter. So here in the column, I passed the column on which I was I was creating the box plot, the numeric value. Here I can say the column is equal to total runs, and then I'm grouping by. Say, in a sense, if you can see, uh, column, it remains the same, total runs, and then instead of using group by, I'm just saying that I want to create box plot by this particular column. So it's just different syntax. The outcome is different. Here you are getting the boxes side by side. The advantage here is that it's easier to compare. So here it is very easy to you can clearly see that, okay, how the median values or the minimum and the maximum value or the range, it changes for the teams. So visually this gives you a better outcome. There is another kind of plot, area plot, not very relevant. I'm just kind of briefly going to touch upon it and then we'll move on. So once again, we have a uh, data of random number, some random integers. So this is the area plot. So what area plot does is that, so now I'm just going to find the percentages. Basically, what I'm doing is that divide each number by the sum and then multiply by 100, which is basically the percentage. So in this case, 21 is whatever percentage it is of the total value in row number or in column number 0. So it gives me something like this. Now the area plot, it exactly does the same thing. So the only thing is that it finds, just the way in histogram it automatically created the bins for you. Similarly here you are automatically getting uh, the values, the percentages. Okay, I'm sorry, I think only if you find the percentage, then it gives you the relevant result. So now and also I'm sorry that this is on axis. I created it on axis 1. So this is not the percentage for the entire column, it is row wise. So you can say at index number 0, these three numbers will add up to 100. Similarly, these three will add to 100. So that's why we are getting three distinct areas here. So this is representing column 0. You can also see the labels. So the blue is for column 0, column 1 and column 2. And you can see how the value is distributed. So as I said, not very relevant. We can just leave it at that. I've also created just a dummy example of area plot. Not something I've seen getting used so much, so don't worry about it. Scatter plot is an important data point. It once again, in case of scatter plot, what happens is that you see the distribution of a particular value in reference to another. So here it becomes important to see how the data is placed with reference to. That's why there is a, now we are back to x and y. So we are always plotting one data against the other. Now, in unfortunately for IPL data, the scatter plot, there is no relevant scatter plot that you can generate because. So what I have done is that I've just created a scatter plot of season versus win by runs. Of course, it's just giving me uniform bars. I mean, kind of, you know, for each season, I'm getting kind of a column. So it's not a very good or a very relevant scatter plot, but we will come back to scatter plot when we talk more about it in CBOL. So you will understand. Basically, it's important to understand how is it used and the utility of it. So we will come back to it. Don't worry about it. I'll have to use another data frame to explain that. So I'm holding that. So with that, we come to the end of Panda's plot. Do you all want to take a quick break? Okay, let's make it quick. 4 to maximum 5 minutes and come back. We've lost enough time. So we have a lot of content to cover. So, okay. So just a quick break and then we'll come back and start with C1. Hope everyone is back. Okay, so Cbon is another Python library, as you can see in the import statement. So it is another library which is built on top of matplotlib. So that is why once again you will see. So it's not an independent plotting library. So it makes use of inherently internally it makes use of some of the matplotlib functions. In fact, some of the commands. Some of the utilities which are not built into Cbon for those you have to still make use of matplotlib. So sometimes you will see Cbon code with some plt dot something. So don't be surprised if you see that because it is designed to work alongside matplotlib. Another very important note on Cbon is that once you are comfortable with matplotlib and pandas plot, your first preference will always be using pandas plot, and there are some cases where you may have to go, particularly when you're plotting multiple figures, and that's where you use that code figure comma axis is equal to plt dot subplot. So those kind of scenario you still have to be comfortable with matplotlib. Cbon, I would say in simple terms, is more like is more nice to have if you are not like we spent some time understanding the code here, the pure pandas code of how did we do the filtering. So if we are at a stage like that, I would say that spending more time on Python and pandas is more important any day than learning another library for plotting. So of course we are going to briefly cover Cbon here, so the content is there for you, but a very high recommendation from my side is that rather than spending too much time on Cbot, you know already how to plot, get more comfortable with Python and pandas plotting, and you can just barely understand and Cbon, and then we can park it for some time, and then once you are comfortable with the rest of the stack, you can always go back to Cbon. Of course, we are still going to cover it, so it doesn't stop me from just briefly introduce you to Cbon, but just something to keep in mind. Don't worry about it. So, so there are the advantage of Cbon are primarily two. There are some of the functions which are or some of the parameters which are incorporated into the Cbon plot. So just the way you created, all your plots using pandas plotting. We created a bar plot or a simple plot will return a line plot and so on, and they all had some parameters, as you remember. Now if you we created a plot using matplotlib on batsman comparison, if you remember. So let me, okay, I think I, yeah, so this is what I was looking at. So we created this comparison of the batsman's run by season. So each season, how many runs did the batsman make? Now, if I directly used the pandas bar plot, what did I get? I got just two bars, each for each numeric column. That was not what I was looking at. I was looking at pivoting the data. So I had to use the pivot to reshape the data into a more relevant format and then call the bar plot on that. And then that's when I got a plot of this format. Now, with Cbon, as I was saying, right, it has some parameters, some more interesting parameters which are incorporated. So now I'm going back on the same data frame. That's when comparison, and this is I've just given you an example of what we did using the pandas plot, that we had to pivot and then call the plot. With Cbon, we can directly plot a bar plot. So when I say x is equal to batsman and y is equal to batsman runs, it is directly giving me the relevant. So you can see batsman, there are two values for each row, right? And then there are two sets of runs. You can directly create a plot in that case. What it gives is that it gives me a central value. So you can see the first De Villiers, there are two values, right? There is a 687 and 513. The output that you're getting is more like 600, which is the central, the average value, which is fine, but not something I was expecting out of it, right? So this is basically it is trying to use its own intelligence that, okay, I want to create a graph of X versus Y, but there are multiple X values and I don't know how to consolidate them, right? I mean, I cannot have two X values here with the same name. So it used its own intelligence and consolidated. But what is more interesting is that, and you can also create a horizontal bar plot. So where I just have to switch the Y and X and then the horizontal bar is created. So there is no bar H as we used in case of Matplotlib. But what is interesting is the U parameter, which is not there in Matplotlib. So now I'm saying that I want to create a graph of batsmen versus the runs, but my U is the season. That means I want to split the data on the basis of the season. So in the earlier case, what was happening was it was completely ignoring the season column. Correct. It has not taken season into account. It just averaged the numeric values on the basis of my batsman, because that's the two columns that I have passed, X and Y. Now I'm passing the third column. So I'm saying X is this, Y is this, and the U is the season. So split the data on the basis of season and the graph got created. The short answer is that in Matplotlib, there was this was the additional part of the code. I had to use pivot. But once you are comfortable with pandas, you will be able to, this will be a very obvious uh, thing to do for you. So in that case, then even matplotlib plotting would become equally easy for you. But all I'm saying is that uh, that is the U parameter does a lot of it replaces group by and splitting the data pivot in many cases. So that's one interesting parameter that you have to keep in mind. So it gives you the correct kind of a plot that you were expecting. Second is the colors are also kind of slightly better with Seaborn. But of course, colors you can control even in Matplotlib. But the default colors with Seaborn are better. So that is the first comparison of the bar plot in Matplotlib versus Seaborn. Then there is count plot. So the number of observations in each category. So we are finding the value count of the winners. So each team won how many matches so far. So Mumbai Indian totally has won 80 matches and CSK has won 79 and so on. So I have to, call the value count and then plot the bar plot. So that this is what I get. The bar plot on the winner count. Correct. Now that is my though I'm using Seaborn bar plot, but I am making use of uh, the data frame which is consolidated here. Now, using Seaborn directly, I can also use something called as a count plot. So, what is count plot going to do? As the name suggests, it's going to do the value count for you. So that's why I'm at every stage I'm trying to give you the comparative code. That if I were to do it using Matplotlib, I would do this. But so I have to first create a new data frame using value count and then call a plot. Now this bar plot could very well have been a Matplotlib plot because I have done bulk of the work here in this code. But now what I'm doing in the count plot is that I'm directly passing the matches. Matches is my data frame which has a winner column. And as you know, the winner column has the name of the winner. And it is the count plot is counting the occurrence of each value in that winner column. So it is giving me the value count. And as you can see, that is the reason. The first match, if you all remember, it's between Calcutta and RCB, and Calcutta won it. That is why Calcutta in the winner column, it appears at the very top. And that is why if you see the order is in that order, the first occurrence was KKR and second was CSK. And it is just for each name, it is incrementing the count, and whatever is the final outcome, that is plotted for you. So SNS dot count plot, it gives you this. Is this clear so far? Are we good? Everyone is fine, right? I mean, there's no response, so I'm just wondering. I don't want to waste time, but at the same time, I don't want to go totally fast and then it totally goes over the head. So just trying to find the right balance. So the first example that we saw is a simple bar plot. The only difference being that we made use of the hue parameter, which took into account the third column, which was not, otherwise we were not able to make use of it. So with the matplotlib plot, we had to first reshape the data and then use. So first we had to reshape the data using pivot and then plot. But with the hue parameter, we were able to incorporate that along with the x and the y axis. And the count plot, what it does is that it returns the value count for any data point. So the number of occurrences. And once again, I could just switch the y-axis. I could say that I want the winner on the y-axis instead of x-axis. And I get a horizontal bars. That is the only difference. Now, the box plot. We just talked about box plot today. And you also remember the box plot that we generated once again. So it's very, very similar to the count plot. So what are we doing here is that we are just making use of, so here, of course, we still have to reshape because this is a lot of uh, uh, editing that has happened on the deliveries, because deliveries is a ball by ball delivery, right? So if I want to find the total run, basically I'm just creating a scorecard kind of a thing. Now in this, I've also added the inning parameter. So in earlier, if you remember, when I created this top teams DF, it didn't have the inning. It only had the match ID. So now I have the match ID, the inning. So whether they made that runs batting first or batting second, and the batting team and the total runs. And I'm once again keeping only the top teams because I don't want to have, just too many bars. That is my only reason. That's why I'm just filtering out the number of teams. So I can create a bar plot by specifying once again. Uh, so my y-axis, I want the total runs, of course. X is the batting team. So I would get five box plots corresponding to five teams in the data, which is, this is how it looks like. Once again, making use of the hue parameter. So that's the reason you can see that the inning is added. So now I want to see, okay, on an average, RCB made so many runs, and these are the, the lower bound and the upper bound and the outliers and so on. But I want to compare how did RCB do uh, batting first versus batting second, because we know there are certain teams which like to bat first versus certain teams which prefer batting second and so on. So we added the hue parameter, And we can see that, okay, RCB fared much better. The median score was much, much higher with, batting first versus batting second. And then there are teams which are more side by side, like Kings 11 Punjab. They don't seem to be having any preference, and so on. So it gives you an insight into the data which you were not able to draw out of the earlier graph. So this is just one example. We are just uh, continuously making use of IPL dataset, but it gives you an idea as to what are the different ways in which you can look at the data to gather more insight. When you have been just given a bunch of numbers, bunch of rows and bunch of columns, and then you're trying to gather insights out of that. How do you do that? So these are various ways you can achieve that. So this is once again a box plot, simple box plot you can generate that remains exactly the same as your matplotlib or pandas box plot. The the special the addition that SNS the Seaborn provides us the u parameter. So it gives us it incorporates basically the u. What it does is that it incorporates a third column, which you cannot by ideally using just x and y values, right? I mean, so if you have to make use of the inning, you have to group by inning and then call the box plot. Then it's going to give a similar outcome. But here it that you're avoided that issue is avoided. I mean, you incorporate your third column also using the u. Is this clear, everyone? Syntax, of course, it'll take some time getting used to. And Seaborn syntax, even I don't remember offhand. Usually, I just have to refer to the documentation. In fact, these are the default plots, which are like, the simple bar, box, violin. These are the simple plots. There are slightly more complicated where even the names are not quite intuitive. So those become quite difficult to remember, but which is okay. I mean, always in programming, you have to make use of documentation. So violin plot in principle is same as the box plot. The only difference being that it's a rotated kernel density. So you can imagine it, visualize it more like, a plot which is rotated. So these are the values. So So I have created just the way we created the box plot. I created the violin plot out of the X and the Y, the batting team and the total runs. So instead of 5 box plot, we got 5 violin plots. And same in the same sense, we have swarm plot, exactly same data, just represented in a slightly different fashion. I'm not even, you know, worried too much about it because it's just kind of giving you the same data. Just Seaborn, it focuses a lot on the visuals, so that's why some of these purely from the representing data point of view, it's not even different from the earlier. So why would you even want two more plots when your box plot is actually doing the job? But these are more, I would say, fancy looking plots. So it's okay if you don't understand or make use of them. So you can also overlay plots. So what I have done is I've actually created two plots here. So there is a violin plot and then there is a swarm plot. But if I just smartly choose the color, so for example, the swarm plot, instead of the default colors, I just picked up the black color so that it's still visible over the violin plots of these different colors. If I remove this color parameter, then you won't be able to see those dots. So now these are two different plots, but representing same data, of course. So I have my batting team and the total runs, and they are overlaid on top of each other. So the overlaying of the plot you can do even in Matplotlib or Pandas. So when you call two commands back to back, then two plots are going to be created on the same figure. So that overlays the plot. As long as you choose your colors wisely, that both the plots are clearly visible and they are not overlapping each other, it will, create the right kind of plot that you would want. So these are the basic plots. We started from here. So we created a bar plot and we made use of the hue parameter. We created the count plot, which is nothing but the value count, only difference being that you don't have to call value count separately. Count plot takes care of it. And then you have a box plot similar to what we used in Matplotlib. Once again, you can make use of the hue parameter, which will also, which will kind of, if you want to create the box plot with reference to a third column. So of course, box plot will always have two columns. One is the x and the y axis, but apart from your x and y, if you want the boxes to be created on a third column, you want the data to be grouped by a third column, you can do that using the hue parameter once again. And you can just similar to box, you have violin and swarm plot or uh, both together. So overlaid. So this is the basic plotting using Seaborn. More aesthetic. So now we come to slightly more advanced plotting. Here, as I was saying, some of the names unfortunately are not very intuitive. So the histogram, which I would still prefer to call it hist, but I mean, though the name is not totally wrong, so it's called dist plot. So the distribution. We know histogram, it gives you the distribution of the value, right, of a particular series. So it's called dist plot. So it's a univariate distribution, right? We are looking at one variable. The histogram is the distribution of one particular, from the pandas perspective, you can say, one column, one data point. It's not, you're not plotting x versus y. It's not, x on one x axis and y axis. It's basically the distribution of data points in a group of value or in a column in simple terms. So it also fits a KD. What is KD? It's the kernel density. So this gives you the distribution, the kernel density estimate. So I have some random integers in the range of 0 to 100, and the idea of the bins remains the same. I'm creating a dist plot of the data, and this is the plot that gets generated. The KDE by default is true, so it creates the histogram and it also draws the kernel density estimate. It's kind of overlaid on top of the histogram. Okay, so now we have for the win by wickets, it's exactly the same code. Here, instead of dot histogram, we are using SNS dot dist plot. We spent enough time on it already, so you know what this data is representing. It also gives you, the central point and what is your maximum value here, and so on. Okay, now it has two parameters, the Seaborn dist plot, KDE and rug. KDE by default is true. So if you don't make use of the KDE parameter, which we did not in the earlier two instances, it created KDE by default. But if you don't want that, you can set it to false. So you do have that option. And there is a rug. Rug is kind of, for each value, it kind of gives you the bars. And it's going to be like this, just a very small rugs at the bottom of the graph. So rug by default is false, but you can set it to true. So if you do, then this is how the rugs get created on the top of the histogram. and there is a histogram parameter also. So in a way, the distribution plot, it's kind of the parent of the histogram that we learned in pandas, because it gives you three different types. So it gives you a histogram, it gives you KDE, and it gives you the rugs, and you can choose any number of parameters to be true or false. So depending on that, you can have any combination of the plots together. So is the dist plot, the distribution plot, is this clear? We are of course going to talk about the distribution in principle. What is the idea of the distribution of the data, and then the standard deviation and all that we are going to talk about when we come to stats. So don't worry if you are not too clear on that part at this point of time. Are we clear so far? Okay. I do understand that we are going a little fast, but as I said, Cbon is not a blocker in any way. So that's the reason. If you have limited time, I would still say that get more comfortable with pure programming, Python and Pandas. So that would take you a long way. Now, the scatter plot. So for creating scatter plot, there are two functions. So we have rect plot and lm plot. So they both draw scatter plot, and as I was saying, with the pandas plotting scatter plot. Yes, and Seaborn it's going to be fairly complicated. So that's what when I started with Seaborn, that's what I said. At least with pandas plotting and the matplotlib, the plots, the names are more, or rather, they are absolutely what the plot is doing. So the scatter plot is called scatter plot, or the bar plot is called bar plot. But in case of Seaborn, some of the names, like even for me, it becomes difficult to remember. If just offhand, if you ask me that, okay, what is scatter plot called? It's easy to remember scatter plot, but it's very difficult to remember LM plot, right? I mean, so yes, that way, it's just you're just going to see more and more functions here. So but that's okay. I mean, what is more important is to have this at the back of your mind that something like this exists, and then obviously when you get to work on it, you always have to refer the documentation, and there's nothing wrong with that. I mean, that's how you have to operate. Okay, so what exactly happens in a scatter plot? So there are two variables, x and y. I mean, we're calling them x and y, but basically there are two variables, and we are looking at the variable in the perspective of the other. So basically, we try to find the correlation between two data points. That is what essentially the scatter plot does, right? And in principle, when you create a scatter plot of two data points, or two different variables in your data, what are you trying to see is that is there any relationship between the two data points or not? Now that relation can be positive, it can be negative, or there could be zero correlation. Now, let's say an example. So, of course, as I was saying, for this, purely for the matches or the deliveries data frame, there are no two columns which on which you can find the direct correlation. I think I have created something, but okay, so let's just go to that example rather than me coming up with something else. So I have done some filtering on the data to get the number of boundaries. So this is the scorecard. So we have each my match ID, of course, will appear twice because you have inning one and inning two, and you have a batting team and the winner of the match, of course, and then you have the score. And against that score, how many boundaries were hit? So KKR made 222 and they hit totally 30 boundaries and so on. Now, if you want to find if there is a correlation between the score and the boundaries, of course, in this case, obviously there is a correlation, but if you didn't know, then what would you do? You could easily create a scatter plot between the score and the boundaries. And in this case, what happens? You get a very, very high, almost a perfect correlation. So, of course, this is also something that when we come to the stats session, the first session on stats and machine learning, we're going to talk about these in more detail. That what do you mean by a perfectly positive correlation or a perfectly negative? So, for example, if your regression line was of this, the slope was a negative slope, a negative one, then that would be a perfectly negative correlation. So, let's say you have house data, or let's say you have salary data of a particular large organization. So there are a million rows, and what you have in your data is the educational qualification and the salary. So the education qualification of the employee is rated, it's kind of ranked from say 1 to 10. It's just basically binned, it's grouped. So 1 being the lowest and 10 being the highest. And you want to find the correlation. So you would say, okay, the education on x-axis and the salary on the y-axis. And if there is a correlation, of course, in this case, once again, you expect that data to be correlated. You would expect that uh, all those people with the education more in the range of 1 or 2, the salary would be clustered somewhere around here. And as you go higher on the education, the salaries also would keep getting higher, right? I mean, the number would be higher, and that would give you perfectly positive correlation. Now, let's say you have another data point in that, and that is total number of years of experience. So you have number of years of experience here, and your range is from say 0 to 20, and then you have the salaries here. How do you think that graph would be in that case? Once again, right? It's the same positive correlation. So less experience means the value would be somewhere here, and then as the number of years of experience increases, the number will go higher. Correct. Now you have, let's say, house price data, where there are once again, two variables that you are looking at. One is the age of the house, and one is the price. Of course, the data would have many more variables, but right now you are interested in finding the correlation between the age of the house and the house price. So let's say the age being 1 year to 100 years. How do you think that would be, if at all there is a correlation between the age of the house and the price? How would that correlation be? If the house is new, the price would be somewhere higher, right? And as the house keeps getting old, the price would keep reducing. So that would be more like a perfectly negative correlation. right? So that is the whole idea of the correlation between two variables. And the scatter plot is ideally used to find and represent that. And the advantage, of course, you can, as we saw, we can create a scatter plot using pandas plot. Uh, we can also create it using seaborn, using LM plot. Advantage here is that it also fits the regression line. So as you can see, the by default fit underscore reg is true. In this case, of course, it wasn't relevant, right? I mean, there is absolutely no correlation between season and win by run. So you are getting totally disconnected values. But in this case, there was a correlation, and I didn't use fit regress parameter. So by default, it is true. So it also fit a regression line. So this is the utility of your LM plot. When I use reg plot, it is giving me exactly identical plot with a slight change in the shape. So here we've also kind of explained the difference between the LM and the reg plot. It is totally, I mean, we can either talk about it or skip it. Uh, Let me just very briefly cover it. Will not linger too much. So LM plot uses reg plot internally. Uh, the main difference between the reg plot and NM plot is that reg plot, it draws directly on the axis, whereas LM plot, it creates its own figure. So when I call LM plot, let's look at it this way. LM plot is a more independent function. So when I call LM plot on a particular data and I specify X and Y, this figure is created of its own using LM plot and the data is plotted. Whereas in reg plot, it works in conjunction with, say, your matplotlib. So for example, we were using figure axis is equal to plt dot subplot, right? So if you want to create an on one of the plot, if you want to create a reg plot, you can do that using you know you can use that with reg plot, but not with the LM plot, because LM plot is creating its own figure and then it's populating it with the data. So that is the main difference. So reg plot can coexist in a figure with different kind of plots. So it can follow the global matplotlib parameters. LM plot is an entire figure by itself. So it cannot coexist. When you call LM plot, it creates its own figure. So as you can see, when I call reg plot, it's a matplotlib level subplot. Whereas this is a Seaborn facet grid. So it does not coexist. That is the only difference. But outcome is similar. Does this make sense? The difference primarily? I have given the explanation here. So of course, you can refer to this anytime. Is it clear, everyone? Just it's when everyone gets so quiet, kind of start wondering if am I going too fast, slow? Is there any doubt? Do I need to kind of cover something again? Let me know so that I know, because I totally understand we are covering a lot of topics today. I can afford to do that because I'm not too worried if Seaborn is not 100% clear. And you, of course, have this as a documentation over and above, of course, the documentation, the official documentation. So you can always make use of this. So is there any doubt? All good, right? Mayank, it's not clear. So what part is not clear? Overall, if you feel just the speed is a little high, I mean, then of course, you just go through this documentation after, oh, you said no doubt. Okay, fine. That's great. Okay. Okay. So the next we're going to talk about is the facet grid. The facet grid, what happens is that we created multiple plots earlier also, right? I mean, when we called group by, so I used an example in box plot, I think. Yes. So here, when I created a box plot for, multiple batting team, so I created it two ways, right? One was using group by. So I said group by dot box plot. So what happened? For each unique group, one box plot was created in the figure, and I had to specify the layout. Right. So there are five box plots generated separately. Of course, I could make use of the parameter by inside the box plot, and then those box plots, the boxes they got generated side by side. In facet grid, what happens? Let me come back to it. Once again, you are able to create those multiple without having to, perform the group buys. So just the way we saw the first example of Seaborn, right? I mean, instead of using pivot, we were just able to make use of the hue parameter, and we were able to incorporate the third column. Similarly, here in this case, we are going to be able to do perform, create. So I'm creating multiple histogram in this case instead of box plot, but I don't have to use a group by. So let's see how is it working really. So what am I doing here? I'm filtering the matches data frame to only keep the top five. So you remember the top teams, how I created, right? I just picked up the top five teams and that list is already there. So I'm filtering the matches, the winner column on the basis of top teams. And I'm also getting rid of uh, the win by wickets, which are not equal to zero. I mean, I'm uh, getting rid of the win by wickets which are zero. So let me first show you how does the matches filter look like. So this is my data frame, right? So only the those winners are there who the top five teams that we generated, and the win by wicket, all the zero values are out. So we have more meaningful data left into this data frame. Just makes the graph more clear and concise and easy to understand. So I can create a facet grid. The only thing is that you have to first create an object in this case. So you are going to create a facet grid object on the matches filter, which is my data frame. And all I have to do is I have to specify the row. And then I can create. So now what am I doing? As you can see, the disk plot, it is existing, it's coexisting here. So I am mapping that with the, so the syntax is of course uh, different. So which is what I was saying earlier also, right? That with the Seaborn, some of these graphs, the syntax is very different. Somehow Matplotlib and Pandas is quite intuitive. So in Seaborn, it's so if you remember, I made use of when I imported Seaborn, I also used the color codes is equal to true. It just returns the plots which are better. So it just kind of automatically took care of the grids and overall the plots, they look better. So that's there in your report import statement already. So you don't have to worry about it. So now for each, so instead of saying, my whatever is matches filter dot group by the winner and then dot histogram. So this is essentially that, right? On my matches winner, I'm grouping it on this particular column and then creating multiple histograms for each group. Instead of that, I could simply create a facet grid object and then create a displot for the particular column, the win by wickets that we are interested in, right? So the grouping over a particular column, the winner column, it happened here in the facet grid. So instead of performing group by, you can directly make use of the facet grid. So I got 5 disk plot, and the parameters of the disk plot, it remains the same, the default. So as you know, the histogram and KDE by default is true, and the rug is false. So which is what happened. Of course, I could have specified the parameter to be something else. I could have said disk plot is equal to the rug is equal to true, and it would also have created a rug here at the bottom. So I got 5 different histogram, corresponding to the 5 unique teams in that. It also created a histogram of win by wickets. I can see. I'll take a look at how to handle that, because I don't want to unnecessarily go into it. We've also specified the bin size here, and as you know, we've spent enough time on the bin size, so we can pass that right now. So this is a slightly different concept, creating the facet grid. So I have not, okay, there is no documentation link on facet grid. Let me just, of course, I'm also going to just Google. So I tried to put the relevant documentation link. Sometimes I miss that. So when you look at the documentation, of course, it will be a little more clear. So you need to understand how facet grid is really working. So as you can see, when I create the object, it just gives me the empty plot, and then I need to draw the plot on each facet. So this facet grid is equivalent to calling, figure comma axis equal to plt dot subplot. Then what it does is that depending on the number that you specify, it creates that many empty plots. And then once those empty plots are generated, you populate those individual subplot using whatever you want to. So in this case, in fact, so, as you can see in this example in the documentation, once the facet grid is generated, they are using the PLT histogram. So you don't even have to. So they can completely, as you can see, Seaborn and Matplotlib can completely coexist, because it's built. Seaborn is built on the top of Matplotlib, just the way Pandas is. So once the facet grid is generated, you can call Pandas, Matplotlib histogram, or in my example that I have given in the content file, I have used the dist plot. So see here they've used the Matplotlib scatter, so plt.scatter, and then you specify your x and the y axis, and then whatever different parameter. And the facet grid, once again, it takes the u as a parameter. So you can keep into account, you can incorporate data of multiple So here once again I'm creating the same okay, this is the example of the LM plot using the U, but let's just go back to the facet grid. So while creating the facet grid itself, you can make use of the U parameter. So you can say that I also want to make use of a particular column as the U. So this is my data. This is the column on which I want to create the plots and the U. And then I populate the figure using the X and the Y, and then this is how the graph gets generated. So it's a two-step process. The steps are first creating the figures and then populating the figures, which is exactly the same as matplotlib. When you say figure comma axis, what are you doing is that you're creating different the figure and multiple axes. So figure is the overall figure. You could have in this case, what is the figure? Figure is this whole thing. That is one figure. But what are the axes? Axes are those individual plots, right? So this is following the same structure, but with a different syntax. So is this part clear? Facet grid, I totally understand. It's a little unusual. Is everyone fine with this? Do go through the documentation. So I have not given the link. So if you have already anyway downloaded the content, anyway, I think getting the documentation link is not a problem, right? I mean, a simple Google search will take you to the right place. So because that has multiple examples, so it just makes things more clear. You're seeing it with a different perspective. So here I made use of different parameters for the LM plot. So this was the dist plot, and as I said, dist plot, it coexists with so it can be a part of the facet grid, or you can create a dist plot by itself. But LM plot is different, right? LM plot, it creates its own figure. So LM plot cannot, for example, coexist with another kind of a plot. So we are back to the score boundary that we created earlier. So we have the match ID, and then there are innings 1 and 2. The batting team, who's the winner, the score boundary, and I've also added one other parameter called whether the team is a winner or not. So is winner. Okay. So the team made this much score, and out of that, so many came from boundaries. I mean, there are these many number of boundaries rather. And then whether, after doing all that, whether the team won or lost the match. So I'm adding these columns so that I can make use of different hues, right? I mean, different parameters. So the first LM plot that I am creating two graphs, right? So we have a score versus boundary, that is the by default. So of course it has the correlation. The U that I'm using is winner. So in that case, what's going to happen? I'm getting two graphs, not one. So the blue graph is representing the is winner value 0, basically is not winner. The team is not winner. What happens in that case? And if the team is winner, what happens in that case? Of course, the data is primarily overlapping. So you're not seeing much difference here. Similarly, I can add another. So you cannot have multiple values passed as U, but what you can have is that now you can add another parameter called marker. So over and above U, I can make use of the marker. So now I'm marking those with separate, so my instead of them the winners is winner value 0 and 1 being separated by color, I've also added marker. So the teams who lost, I mean who did not win, they are represented by this red dot, and the Teams that won are represented by the blue crosses. So this is using the marker parameter. And now I'm adding one more column. So adding another variable. And now my new variable that I'm using is the batting team. So depending on the batting team, I'm getting multiple graphs. So the first one is for RCB, then CSK. So for each unique batting team. So of course, I'm going to have 5 different graphs, and each graph having 2 lines corresponding to one for the winner, because I'm also making use of the hue parameter. So as you can see, I'm just I created a simple LM plot earlier. Then I added the hue parameter. On the hue, I also showed you how to use the markers, and now I'm adding the column parameter. So it's over and above hue, it's also uh, keeping the column into mind. So it's creating multiple graphs. All of this is happening without using group by. So that is probably the big advantage. So, and the last, you also have a row parameter. So I want uh, the data to be split on the U, of course, it's still the same. So I want two graphs, one for the winner and one for the loser. So 0 and 1. Over and above that, I want the column to be inning. So inning 1 and inning 2. How's the performance? And for the row being the batting team. So for each, so RCB inning 1 and inning 2. This is how the, this is the correlation between the score and the boundary. Similarly for CSK and for all the teams, which are present here. So these are the various parameters in LM plot. Is this clear? Primarily, the part from here on, of course, it's slightly more advanced. So it's creating, multiple values, which typically you would do using group by in case of matplotlib. But just purely the hue parameter is definitely quite useful. So overall, in Cbon, for multiple type of plots, as you saw even earlier, that you can make use of the hue parameter, and that makes plotting fairly easy. Is that clear? Finally, how do you control the size and the shape of the plot? So as I said earlier, uh, Seaborn, it doesn't have any figure size equivalent for most of the plots that you are generating, using the matplotlib primer. So what you're going to do is that you're going to create the plt.subplot and specify. We use the fixed size, right? So that parameter remains the same for matplotlib. So we create a figure size. I want 12,5, and then I create the rect plot. So what happens? This is how the plot gets created. Now, uh, can I do the same thing using LM plot? So let me add here. I want to do the same thing. I want to control the size using LM plot. Is this fine? Anyone? I want all of you to think about this. So in principle, as I said, LM plot and rect plot, they both create the scatter plot, and they also draw the regression line, because in principle they are uh, representing the correlation, right? Now tell me, I was able to control the size of the figure using the matplotlib code of and the parameter fixed size. How do I do that using lmplot? Can I use this code? If I execute this, what will happen? I want all of you to think and try and answer this. Is my question clear? Okay. So the question here is okay. Anyone else? I want more answers here. I'm trying to see if you all are following along. Anyone? I want more answers. I want to see. If you didn't understand, you can say that. If you want to make a guess, you can do that. But I want some answers here. So what happened, everyone? It's just Saturday morning. You couldn't have gone to sleep. Was I so boring? Okay, you're confused with the question. So my question here is that so we did talk about rec plot versus lm plot, right? When I started off, I created uh, the scatter plot using reg and the lm, and I said that you can create, using the where was it? Yeah, the reg plot and lm plot. So they both draw the scatter plot between two variables, right? And then they fit the regression line also, unless you make use of the parameter fit regress is equal to false. So this was lm plot, and reg plot does exactly the same thing. So, and then we talked about the difference between the two. So this was the reg plot and this was the lm plot. This is where we were, right, originally. And then we talked about the difference. What was the difference between the two? Any idea? I mean, do you vaguely remember? Okay. So what I said was that reg plot is an axis level function. What does it mean? So when I create subplots using matplotlib, when I say figure comma axis or axis is equal to plt dot subplot, what happens? The whole collection of axes is one figure, right? That figure is drawn uh, or created, and then the axes are the different axes. So when I say recplot is an axis level function, what does it mean is that it draws the plot directly on that particular axis, which is already generated. Or you could call it and then the axis gets created for you, in which case it's going to be single axis. What happened here, right? So here you didn't have to say figure comma axis equal to plt dot subplot. Fine. Uh, the difference here between LM and reg is that LM is a figure level function. So it draws its own figure, and it also has parameters to control the size and the shape. So that is the difference. So now coming back to the question, what I did here was, when I wanted to control the size of my reg plot, what I did was I used it along with the matplotlib figure comma axis, and I changed the figure size, correct? And then I populated that axis with the reg plot, and the shape changed. This is not the default shape that you get, right? I mean, the figure size is 12 comma 5. Now if I try to do the same using LM plot, what happens? So I get this. Okay, I'm getting score boundaries. Okay, so now let me execute this. So what happened here? I have now executed this for you. So now my question is kind of next level. So I got this empty figure, which I'm assuming is 12 by 12 comma 5. And then I got this LM plot. So what exactly happened here? It didn't work the way it worked with the reg plot. So why is that? Now it's a slightly rephrased question, and I want more of you to participate, at least so that I know that everyone is following along. Okay, yeah, but you also need to try and answer. Not clear. Okay, fine. That's fine. You tell me that also, it's okay. Just I need to, because there's no point wasting a whole 3 hours worth of session, right? I mean, we need to make sure that we are drawing maximum out of it. Yes, it is exhaustive. That is something you need to kind of, once the session is over, you should revisit, and you should, I hope you have already downloaded this. So go back to this document and, execute the code line by line and see what's happening. Yeah. So the simpler ones I just kind of revised, and hopefully they are fine. This is a slightly different or slightly difficult concept. So that's why I've paused here, because there's no point just moving on when I knew that you all wouldn't have understood this fully. Okay, so let me uh, uh, explain what's happening here, right? So in the first case, what happened, as I said, reg plot, it's an axis level function. So when I say it's an axis level function, it can coexist with on a larger figure created by matplotlib. So this could very well be a part of one of the multiple plots created using the subplot parameter, right? So we used this in the last session. I hope you remember creating multiple plots using plt dot subplots. Right. So rect plot could be just one of those plots on one of the axes. That is the key difference here. lm plot, as I said, it's a figure level function. So lm plot cannot exist alongside or on a particular axis. When I call lm plot, it creates its own figure. So here what is happening? Why are these two plots getting generated? These two are actually giving out these outputs respectively. So the output of my first code is that this first figure got generated, which is 12 by 5. And uh, it did not get populated with anything because my following code is not a rect plot, it's an lm plot. What did lm plot do? Lm plot is not going to plot on this figure, right? Because it's a figure level function. lm plot wants to create its own figure, which is what it did here, and it created a plot on that figure. So that's what happened here. So even though they create exactly same kind of plot, the inherent difference is that rect plot, it's an axis level, so it coexists with the other figures and the other axes, whereas lm plot, it would create its own entire figure. It has to occupy the whole figure. Is that clear now? So now the next question is, how do you control the size in that case? Because you cannot use the figure size of the matplotlib. So obviously, I mean, it's taken care of. So there are the parameters called, so we have a size, which is the height in inches. So this only gives, using the size, you can only control the height of your figure. Okay. Because this is a figure level function, so you don't even have to worry about different axes. It's only just one figure. So now I have increased the height. The default is 6 inches. So I changed it to 8. Now what happens if I want to also control the width? For that, there is no width parameter, but there is a parameter called aspect. So it's basically going to give you, you will be able to control the ratio. So aspect is the ratio of each facet. So when I say aspect is equal to 2, what does it mean? That my width is size into 2. If the aspect was, so now my width became 12. So now my this figure is 12 comma 6. Rect plot does not have size parameter. Rect plot, you have to control the shape and size using the fixed size. And here you can do this. So now if I uh, keep the size to be 6 and change the aspect to 0.5, what kind of graph would you see? What would be the dimensions of the figure? I'm making this 0.5. If I execute this, what will I get? Anyone? Yeah, so now my this is the kind of, so now my figure size is more like 3 comma 6, right? As I said, uh, this length is the size multiplied by aspect. So this is equivalent to figure size 3 comma 6 in the case of matplotlib. So when I make the figure size 3 comma 6, this is exactly the plot that you get. Correct. So the size is nothing but the height is 6, but the aspect is 0.5. So this value is just the half of the height. And that's exactly what is happening here. Is that clear now? Okay. A few other plots. Okay, we have around 10 to 12 more minutes. Let me just quickly see what. Okay, we are almost done. Do you want me to finish this, or you just want to solve doubts and then we only just a couple of figures left, but if you think it's already overloaded for today, I can kind of uh, hold this and answer any questions. I'm fine both ways, but you want to finish this, you're fine, right? Yeah, I don't want anyone to feel that okay, it was just too much and you don't even know what happened. Yes, and I can also probably do a quick recap in the next session. I'm fine with that. It's just that there's always this fine balance between the time versus how well you all have understood. So, okay, so the next is the pair plot. So, where what are we doing here is that these are multiple plots. So we can pass a list of variables. So you can see here the and for each kind of plot you can see the kind of figure that is getting created. So you can see the here the figure is the pair grid. So now my x variables are score and inning. So in the first axis I have score and the second one is the inning. Y is the boundaries. So in the first plot what happened? I got the reg plot. Of course both are the, because the kind is reg, I have specified the kind to be reg. But in the first one it's score and boundary, and second one is inning and boundary. Of course inning and boundary, there seem to be a slight negative correlation because first innings probably more boundaries are hit. So you can combine the plots. So that is the pair plot. It combines the reg plot, you're using the kind, and the pair grid. So we are able to get the relationship between the data variables. Once again, we can make use of the hue parameter. So now we are getting multiple. So that remains the same. The aspect of hue, it is available in most of the plots. So that is multiple plots. So if you want to find the relationship between more than two uh, in one figure, so you can do that. Of course, the relationship is always going to be between two variables, but you are able to create two graphs side by side. Now, similar to pair plot, we have joint plot, but in this case, your x and y remains the same. In the first case, what was happening in the pair plot, you were uh, uh, plotting multiple variables. In this case, the variables are the same, only the type changed, the type of the plot. So we have the score and the boundary, and we are getting uh, the scatter plot of score versus boundary. The only difference here is that you are also getting the histogram of the distribution of each variable, the score and the boundary. So this is the default setting of the joint plot. As you can see, I'm not using any extra variable. All I'm specifying is x and y, and the plot is generated by itself. So there's nothing, I'm not making use of any special parameter here. So joint plot by default will return scatter plot along with the distribution, the dist plot of each individual variable. Of course, I can, as with any plot in Seaborn, you can add the parameter to make it slightly more interesting. So I can say kind is equal to regression. So it added a KDE and it also added a regression line. And in this case, you can see it also added the Pearson R, the correlation coefficient. So in this case, it's a very high, 0.89 is almost close to 1, right? So very high correlation, positive correlation between score and the boundaries. So you can see that clearly using the joint plot. All that we added was kind is equal to reg. So the pair plot and the joint plot. We are getting two types of plots in one figure. The first one, the pair plot, we are plotting multiple variables. So it's one variable against, so score versus boundary and inning versus boundary. So here more than two variables you are plotting, but we are creating multiple uh, axes for that. In joint plot, it's kind of uh, opposite of pair plot. So just the two variables, but we are getting two different types of plots. So we're getting a scatter and we are also getting the histogram, the distribution. And very classic, what you would do, the use of the pair plot is just call it on the entire data frame. So here, instead of specifying the x and the y, so here what did we do? We passed a list of x variables, right? And the y remained the same. I can, so there is iris data set. How many of you are aware of iris data set? I think I just in the data set when we introduced in the first session, I think I talked about it. This is highly used for machine learning, introductory machine learning. It's a very small data set, just four variables and 150 rows. Uh, it's used a lot academically. So I want to, so these are the four variables: sepal length, sepal width, petal length, and the petal width. Now if I want to find the correlation of each and every variable against the other, ideally what you would do is that you would simply call the pair plot and pass the entire data frame. So I'm not uh, specifying any x and the y. So for this, the variable against the same variable, why do you think is this histogram getting generated across the diagonal line? Anyone? So I'm getting a scatter plot throughout except this diagonal line. Why is that? Any other answer? Yes, x and y are the same. So we are not dealing with two variables. So we are, so when you try to plot petal width against petal width, I mean it doesn't make sense, right? I mean when we create a scatter plot, we are plotting the distribution of one variable against the other, right? So when it is the same plot, when it's just one variable, what did we see today? something we spend maximum time on, right? I mean, when you're just looking at one variable, all you see is the distribution of that variable, and the distribution is created using histogram. So that's exactly what we are getting. Yes, exactly. So it's just very intuitive, but you need to understand why is it happening. So the diagonal line, it gives you histogram, and the rest of the places you are getting the scatter plot. As you can see, the sepal length versus sepal width and this plot, they are kind of the mirror image, right? It's flipped because it's the same value, sepal length versus the sepal width, and this is also the same, but it is sepal width versus the sepal length. So your x and y are flipped, and that is why you can see that similarly this and this figure. It's the same variable, but when you switch the axes, uh, the plot will look different. So just need to understand how, what is this figure representing. So as you can see here, it's just, it just gets flipped, the values. Okay. So that is the pair plot without specifying x and y. For a relatively smaller data set like iris, it makes sense. Instead of passing the list of the columns as you did in this case. So instead of in the x variable, we passed multiple columns here. So because here there are anyway only 4 columns, so we could directly create a pair plot for each variable against the other. Finally, we'll talk about the heat map. Once again, it uh, what it gives you is the correlation. So the correlation coefficient. Let me execute so that I have the iris data loaded. So this, you can see the code that I have used. So there are some of the default data sets loaded in Seaborn. So Seaborn sns.load underscore dataset, and there are various datasets available. You can check the list of datasets available in the documentation. So I've just made use of that. I'm not making use of any CSV here. So just so that you know that you can load some datasets directly from Seaborn. Correlation, it does the heat map. It gives you in a way it gives you the same outcome as the pair plot. Only thing is that the representation is different. So what is happening? Once again, we are getting those 4 by 4. Anyway, whatever is the number of variable, it's going to be that number by that number matrix. And once again, the diagonal. So now we are looking at the correlation coefficient. So that's why in the case of pair plot, we were just creating the graph, we were creating the scatter plot. And at the diagonal line, we were getting a histogram because there's no point of plotting that data against itself. Now, if you want to find the correlation of a data against itself, correlation of a particular variable against itself, what is that correlation going to be? It's going to be always perfect 1 correlation, right? I mean, the coefficient is 1. So always in the heat map, this diagonal line is going to give you 1, right? Because it's that column against itself. And at the rest of the values you can see. So you can see here that the sepal length and the petal length, they are highly correlated. So as the sepal length increases, the petal length will also increase, and vice versa. Similarly, the sepal length and the petal width are also correlated, but sepal width and sepal length, they don't seem to be having any kind of correlation. So it's important to understand that a negative, of course, negative 0.43 is, it's still a negative correlation, not a very high one. But let's say if you had another value which was a negative 0.9, then that's also a very high correlation. So, but that's a high negative correlation. So the variables are inverse of each other. So as one goes up, the other goes down. Whereas any number which is close to 0 is, it conveys that there is no correlation or very less correlation. So I've just given you two examples. One is by simply passing the data dot correlation, in which case it creates the plot, but the annotation is equal to true. It also gives you the correlation coefficient. So that makes it a little more clear. I think I should also use the color map here because this color is just terrible. But even here, yeah, it's difficult to see, as you can see, without annotation. Annotation makes it a lot more clear. So highly recommended, unless you are creating a 10 by 10. Even for a 10 by 10 matrix, it's still better to have the correlation values. So the heat map is something that you would have seen, right? I mean, in some of the presentations, or if you are already visiting Kaggle, that even in Kaggle you would have seen. So that brings us to the end of visualization as a topic. Uh, we're going to talk about the advanced topics of pandas in the next two sessions, and that will bring us to the end of overall Python and pandas and visualization. And then we'll move on to the statistics and machine learning. I said this, I think, a week or two, I think, in the last session. I would reiterate, now you all are ready to start at least visiting Kaggle. Is anyone doing that already? I said that, allocate 10 minutes of your day every day to Kaggle. Did anyone start that? Just start by looking other people's kernels. Just look at Python kernels. Please do that. It's an incremental, it's a habit. So try to develop that. Yes. I can only recommend, right? I mean, I only have that much control. So I would just say that again and try it. I mean, it'll help. So here is your feedback link. I already shared it all of you. And any questions at this point? How are you all finding the sessions up to this point? Also, I'm getting very few feedback. So is there any issue? I mean, many of you are not filling up the feedback form. So please try to do that before you exit. It is absolutely enough if you are comfortable with Matplotlib and Pandas. See, it's like adding one extra group by. I would still do it over, bothering myself with Seaborn code, right? Because group by you anyway have to learn. You can use Pandas otherwise. So Tableau is a package in itself. What happens with Tableau is that so overall concept of visualization you still need to know, because otherwise you don't know what kind of plot to generate. Or as I was saying, right? I mean, there are some certain norms that certain kind of data is represented in a certain format. But Tableau, it's more like uh, the drag and drop kinds, right? I mean, so you have your data loaded, and then with a click of few buttons, you are able to create the graph. You still need to. So your role as a analyst, where does it help? You is your understanding of how would you represent the data. So that is still something that needs to come from you. But Tableau will do the job easily for you. You won't have to code, so you won't have to explicitly use your Python or Matplotlib code, or create a loop, or so that's the difference really. It's used a lot in BA, the business analyst kind of positions. Basically, anything non-programmer kind of a role. Yes, advanced pandas is. So yeah, you will see. It's There are certain advanced topics in data that you need to understand. Like I showed you the pivot today, right? I mean, when we were doing. So pivot is a very, very important concept overall in the data. So even when you sometimes see the jobs, particularly the Excel kind of a job, which are not very hardcore programming, all they expect you to know is that, you should be able to use pivot. So it's a form of reshaping the data. So it's an important concept, and there are a few other which are used for machine learning. So that is all session 9, and the last session, the session 10, is uh, the web scraping and getting data from different sources. Yeah, thanks, Mayank. Have a nice weekend. Do fill up the feedback form. Some people have already started exiting, so those who are here, fill up the feedback form, and I will also close the session if there's no other question. Yeah, thank you, and all of you have a nice weekend. Thanks, Deepa. Yeah, yeah, sure, Jasmine, I'm here.
Hi Vaishali, are you able to hear me?
Yes, yes, tell me.
So I had a question like from the beginning of the session, like as I know, like we are going through this data analyst courses, but in net, like whenever I browse for jobs or anything, everywhere I do see it's all about big data analytics. So do you again like suggest that after doing this course, again I have to spend time and learn the whole of big data analytics, or this course itself we have a good job prospects with this?
Big data, see, so big data, there are different, you can again, once again, split it into different parts. And it is all linked to your knowledge of programming, knowledge of SQL, because whenever it comes to data, of course, SQL becomes important. So I'm not 100% sure about the jobs. Like I saw your mail and we had a couple of mail exchange. So Bangalore specific, I'm not too sure. Uh, how does it? What is the market? But in fact, here when I see mostly the data analyst kind of a position, what I see is more a combination of SQL, Python, some of them more Excel, but pure data analytics using. So you're talking more like the pure. They just ask for
Yeah,
Hadoop
I'm talking
and
like if
nothing
yeah
else.
after this course like data analyst with Python, like is it sufficient to get a decent job, or again we need to do something on top of this?
I'm not too sure about the jobs there, but see, already you are into programming. So, what
Yeah.
one thing that I will tell you is that for the data analyst job is that it's a very uh, it's a programming field. So they look for most of them. They look for a fairly good programming background. So anything else, it comes kind of on top of it. So if anyone says that okay, programming is just barely enough, programming is good enough, that's not true. I would definitely say that. As far as
Okay, because
big data is
we,
something that everyone, it's become more like a hype, and I won't say that it's not important. But the the topics, they are more so. Uh, Hadoop, it's basically based on the top of the core programming and core SQL.
Yeah, so for this particular Python and pandas, after knowing this, like I just want to know the opportunities in the job market. So, I mean, I don't want to go to big data, but that's what I asked you. Like, is it necessary to again learn that, or with this only we will get enough opportunities in the job market, like
No, you
good
should get
jobs?
opportunities without that. So I won't know purely Bangalore. I can still search more, or I can check
Yeah, I
there.
mean, yeah,
With
India.
that's what. So, but here when I search, it's never. Uh, in fact, data
You
analytics. It
are
does not even.
located in some other place?
I'm in San Jose.
Oh, okay, okay.
So yeah, so I don't see the kind of relation between the two here for sure. What one thing that I
Okay, okay.
see, and I that's what I'm repeating, is that the core programming, the programming has to be very very solid. So uh, that is something which is unavoidable.
Okay, thank you so much.
Jaismita, here one
Have a
point I
nice
can
weekend.
add. Sridevi here.
Yeah,
I'm working in this field
yeah,
only. So this whatever we are doing the course is the beginning for the data scientist. So
yeah,
if we are very familiar with the algorithms and all statistical programming thing, then it would be good job. We can get the good job for the in the data science field. If it is a pure big data analytics means we have to take the SQL related stuff. More knowledge is required in addition to the Python or and all.
yeah, yeah,
That's
yeah.
my experience in the
Okay,
job.
okay. Thank you. Yeah, we can talk on this more.
Yeah.
Yeah.
Yeah,
Okay,
Sridevi
thank
is
you. Have a
already
nice weekend,
working in
everyone.
that field, and I think are you based out of Bangalore, Sridevi, or
Yes, yes. Yeah, I'm based out of Bangalore, Vaishali.
yeah? So I think she's your reference point. Catch her. So
Okay, thank you.
yeah,
Yeah, bye bye.
thanks a lot. Okay.